Today we're going to talk about three-dimensional coordinate systems. So just like in 2D, sometimes it's not easy or not better to measure things in terms of x and y coordinates, and we have new coordinate systems that we want to use. And we want to be able to understand how to work with those and also want to understand how to do change of variables type stuff for integration. The easiest coordinate system from this list is cylindrical coordinates. Cylindrical coordinates are an awful lot like polar coordinates. What they do is they say, okay, just like with polar coordinates, let's substitute. X is r cos theta and y is r sine theta. So these are the ordinary formulas for polar coordinates from 2D. And then we leave the third variable alone. We don't change its name. We don't change what it means. We don't change anything about that. That's the formulas for cylindrical coordinates, and they're very, very useful for expressing shapes that have some kind of round horizontal slices, but are kind of more straightforward in the vertical direction. So here, physically, the z-coordinate is height, r is distance from the z-axis, and theta is an angle coordinate. So let's draw out a little bit about what cylindrical coordinates look like. So here's our coordinate axis, x, y, and z, like so. And we can draw what happens, what are the different things we get when we write down what's the z coordinate, or what's the r coordinate, or what's the theta coordinate. So for example, if I set z is equal to 0, those are all the points that are of height 0. That gives me a plane, the xy plane. Whereas if I set z equal to 1, that's a plane that's a little bit higher up. And if I set z equals 2, it's a plane that's higher still. So that tells me what the z coordinate is doing inside cylindrical coordinates. By contrast, the r and theta coordinates tell us something different. So if I'm looking at all those points with r equal to 1, those are all the points that are a distance of 1 from the z-axis. And that gives me a cylinder centered at the z-axis, like so. If I instead look at all those points with r is equal to 2, that nests inside a slightly larger cylinder, and so on and so on and so on. So my r coordinate is always supposed to be positive or 0, and it always tells me how far away I am from this vertical spike, the z-axis. And finally, the theta coordinate is in terms of the x and y plane. It tells you how far I have to get if I start above or below the x-axis and start to swing out at an angle towards the y-axis. So for example, in terms of 3D coordinate systems, theta is equal to 0 is the vertical plane that's above the positive x-axis. If I do theta is equal to pi over 2, that's 90 degrees. That's rotated all the way from the x-axis to the y-axis. If theta is equal to pi over 4, that's halfway between them. That lives over top of a line that's 45 degrees between the x-axis and the y-axis. And so as you change theta, you kind of get this sweeping sequence of sheets that live over top of the radial lines that we usually have from polar coordinates. So that's what these three quantities in cylindrical coordinates tell you.